Yeah, so my name is Rostyk. I'm a technical sales engineer here at LAVA Computers. I graduated mechanical engineering in 2020 and have been working as a technical sales engineer here at LAVA for a little bit over 3 years now.
Is that like a combination of marketing and the science behind the product? How does that work?
It's very close. It's more of a sales and engineering role. So it's that smushing of those two things together. So it's basically an interface between obviously the customer, but also the sales people and the engineering. So trying to take some of the very technical things that are going on, filtering them through for things that are relevant or easier to understand, or reshaping them into a way that obviously a customer who doesn't have background in batteries, background in all these different subjects, in a way that they can understand it.
Battery protection is something that has become really hot, I think, in digital signage with kiosks and so forth. We've covered several industry events, including restaurant franchising and hotels. Can you give us the lowdown? What's the basics? What is this battery protection? Why does it matter?
Overall, anything that involves a battery, you obviously want to get the most life out of it. You want to make sure that not only are you getting life out of it, but you're getting efficiency. Because that is either a cost item. So from a business perspective, the longer something lasts, the more ROI, the happier customers are. So the standard kind of rules of business apply. From a user perspective, there's obviously those aspects of when I buy a device, whatever that may be, I want it to last as long as possible. I want that user experience out of it. So it's a holistic concept of protecting batteries for that user and business experience and positives. And obviously a little bit of an environmental thing. The longer something lasts, whatever that may be, not just batteries, the less you're replacing it, the less turnaround you have, the less new materials you're using. So it's this very broad ecosystem of reasons.
Recently, I was staying at a line of hotels, and I noticed instead of a clunky old CRT monitor from the 90s that I remember, they had like literally Lenovo tablets or what have you on swivels at the check-in station. They're swiping and touching, no keyboards necessary, which is brand new for me. Is that a use case where people can start protecting their devices better?
Yes, and that's actually one of those, I'd say, hidden use cases that a lot of people don't think about, because most people will immediately go, well, I have a phone from XYZ manufacturer. I want that to last as long as possible. I want my phone to be around for 2 years, 3 years. That's a pretty normal life cycle. Where a lot of people don't realize is, well, if you're taking off-the-shelf tablets or devices with lithium-ion batteries built in, you want to make sure that that doesn't become a weak point of your system. And that example that you have is actually a very good one, in my opinion, because you have a tablet that's running 24/7. Obviously, it's going to be plugged in all the time. So people naturally go, well, if it's plugged in all the time, there should be no problem. There's actually problems with doing that. And that's one of kind of those tips and tricks of how to make your devices last longer, is not to have them be plugged in all the time, or to mitigate that in certain ways. And how that translates into, for example, the hotel and ROI is that there's no degradation. So even though you're always running your battery connected, that might actually decrease the lifespan of that battery to the point where you might have bloating occurring in the extreme. You might start having kind of this where the moment there's a power outage or any sort of glitch in the system, because that battery has degraded to such a point, it's basically not a battery anymore. It's now just become this big capacitor that isn't really doing much. So the moment that the power is lost, it just dies because it can't hold its charge anymore, which obviously doesn't work anymore. So those are these kind of hidden areas where, yeah, battery protection is actually something that really should be thought of as part of the process.
How does the science work? How does one protect a battery in this way?
The first thing, if possible, do not continuously charge your battery. And this goes for B2B applications, B2C applications. When I talk to a lot of people, the first thing I tell them is, don't charge your phone overnight. It's the first thing that people think of, because lithium-ion batteries do not like being overcharged. What is overcharging? Overcharging is just a name that's used for getting it to 100% and staying at 100%. So that trickle charge. These are common terms that you've probably heard of. Trickle charging is a common term you use for your car battery. Very different principles, but that's where you've heard of trickle charging. That's also an aspect of it. What works for one battery type, so like your car battery, does not necessarily work for something else. The analogy I use is, if you want to be a long distance runner, you use a very different training routine than if you want to be a power lifter. Not everything works for every single battery, and to be cognizant of that is very important. So yeah, don't overcharge it. Don't keep it at 100% if at all possible. If you can disconnect it when it's at 95%, you're already doing better than sitting at 100%. That's very important to remember. Now, a lot of manufacturers have started really trying to put in software that's able to detect that a little bit, but there are always, and this is not trying to say that they're doing anything bad, but there are physical limitations to what can be done in software, what can be done in hardware, and that's why these good practices are still important. Because when the device is on, and this is something that most people don't understand is, or don't know about, is that when a device is on, you have obviously a flow of charge in, so you're charging through your charger, but you're obviously using it at the same time. So this battery becomes kind of like a bucket with a hole at the top, a hole at the bottom. Now, the computer inside, what's called a charge controller, think of it as just a computer that deals only with the battery. Its only job is to make sure that the battery is being charged in the best, safest, and healthiest way. It's kind of got multiple roles to do. It gets confused because it's physically impossible for it to predict what the outflow of energy is, because that's always changing. Your processor's turning on and off. If you walk up and start, using the tablet, obviously it's going to be very different than if it's in a standby mode. So it's doing the best job it can with the tools it has and with just the physics that it can do. So it'll always try to a little bit overcharge, err on the side of caution, going, well, having 100% battery, that's what the user wants. So we're always going to just take a little bit extra charge just in case. And that's where things break down. And that's why it's so important not to be plugged in all the time, because that controller just can't keep up in many ways.
Is there a side of sustainability related to this battery protection?
Very much so. Very much so there is. The longer a battery can last, the less you have to replace it. Now, there's a lot of stuff talked about the whole concept of reusability and replacement and how that can impact sustainability from that perspective. The other thing that isn't talked about all that much is the fact that lithium, the process of refining lithium, and not to get super deep into the weeds, but the process of refining lithium is very dirty. It is just the way things are done, and it's not something that we can't come up with a better technology. It's just it's the nature of the beast. So the less lithium that we need to refine and all of those extractive processes for all these heavy metals, the less obviously that has an impact on the environment, the better it is. Also, the most efficient way that batteries are built today is not necessarily the best way that they can be recycled. So there's this problem of, to build a really easily recyclable lithium ion battery costs something that, it would push your laptop, your phone, probably up by another $100. Now, that's just me kind of a guesstimate. So it's not an educated statement, but it's a guesstimate. It
Wow.
would make it very, very expensive and actually would lose efficiencies. Size efficiencies do become a factor. Now, there's a lot of research going on. There's one that I recall, I'd have to find the article, but where they are working on it, where there's a university in the UK that is really trying to come up with better ways. But it's just an emerging technology. It's an emerging concept, and there are real world barriers and problems to that. So, I mean, we've got some of the brightest minds in the world working on this.
Well, it sounds like this work, sorry to jump in, but with the EV revolution, it sounds like that could also affect the cars and the buses.
Yes.
And so forth.
Very much so. And that's the thing, is also that there are, and it's only now that we're looking at lithium as being such an important resource. We're only now starting to really take a wide picture look of how much lithium actually exists on the planet. So, it's kind of what we've heard about with fossil fuels. There's very good estimates about approximately how much is left, where it is, how much can we get at it. We're starting to do that with lithium. And there are starting to be very big questions about how much lithium really is out there. It is a very abundant element, but is there enough to be able to replace all of the things that we use fossil fuels for, or all the all the different portable devices that we have, all the EVs that are starting to be in? Realistically, if we're starting to put everything into EVs, that's a lot of devices. Now, can we achieve this just by mineral extraction, or are we starting to see that the only way that the math is going to work is by recycling and trying to re-extract what was already built, so all that e-waste that exists?
So do you think we'll eventually, and this is kind of getting super woo, right? But do you think we'll eventually get off of lithium? Will we discover new ways to store power that are better?
Personally, I believe yes. Now, obviously, this is very much so just a personal statement of mine. There's a huge debate going on in the communities of what is possible, what is not. The reason why I say that I personally believe that that will be the case is it's the same thing as when we had the internal combustion engine. Most people said, this is the most efficient, this is all we have, until we had the EV revolution. Before the internal combustion engine, a horse or a donkey was. So as technology changes, our mindset changes, the world changes, and sometimes that does take time. But there's very cool research going on in terms of everything from saltwater batteries. It's an emerging piece of research kind of trying to just use salt water. And that's looking a little bit at the concepts of, well, what happens if we have a natural disaster and all of a sudden these massive batteries break? We now have a lithium spill. Well, we've seen with cars, obviously, lithium fires. They are very difficult to deal with. Lithium. So all of these different factors are driving very different research. And also,
wait, so is that why on the airport they always say you can't have lithium in your bag? You can't have a battery in your bag?
That is one of the factors. Yes, is that it's got to do with basically runaway fires. So lithium, when it gets exposed to basically water, moisture in the air, it can, not always, but it can turn into basically a chain reaction that is, you can't really stop it. It will basically have to burn itself out, and that goes with any lithium device. So this is not picking on EVs or laptops or otherwise. It's just a physics thing, or a chemistry thing, actually, rather.
Well, because I was having a nice soak in the jacuzzi with my laptop, and suddenly I thought, is this a good idea? So now I know not to do that anymore.
With that respect, I would actually say it's more of, if your laptop falls into the water, that's where you're going to have a problem. The lithium batteries are very well built. They are actually built into this plastic enclosure that's why you see battery bloating, is that spicy pillows thread on Reddit that some people sometimes like to look at. They're well in kind of built, but the issue is that what happens if there is a crash or a natural disaster or something that breaks that barrier? Now you have a problem. Now you have that environmental impact. So that's what I really like about batteries, is that when you talk about one aspect, you're really just talking about multiple threads. The world is an interconnected network, not just in the software world, even in the physical world. And batteries are a very interesting case study within that, because you see them affecting mining, you see them affecting economics, you see them affecting recyclability, research. So all of this goes together. And just to add to the point of research, lithium-ion batteries right now are kind of the main thing that we're talking about. But we're seeing research that realistically you're probably not going to see coming to your next mobile device, your next laptop.
There's so much research and development and testing and...
Exactly, but they also probably won't work for the size that we're talking about. But there's some very interesting things going on. For example, Australia, I believe it's Australia, that has just piloted one project, which is what's called a sand battery. Now, calling it a sand battery, it's a very catchy name, and I understand why they did it. But it's basically a thermal battery. So looking at different regions and different applications, and actually having different technologies that solve the gap, and to kind of bring in the environmental. We talk about wind, solar, nuclear. It's never just one technology that solves the problem. So batteries are going down this really interesting path, where it really depends what application you're talking about. We may have different batteries for it and different technologies behind them.
But in the meantime, I love that it kind of comes full circle. If I'm a digital signage professional who's passionate about the environment and also the ROI and saving money, not replacing my devices, not throwing them into a landfill and contributing to this massive e-waste, investing in good battery protection, it sounds like a win-win on all sides.
Very much so. And the beauty of it, in my opinion, is that there's some very base things that you can do to just get a little bit more life, to be a little bit more responsible with it. So first one is what I said: don't try to charge it all the time. If you can't do that, in other words, your application does not allow you for it, look into mitigating the amount of heat that you're generating. So if you can tone down the screen brightness, if you can make your processor a little bit more efficient, put a cooling system on it, even if it's a passive cooling system on it. Do some battery modulation. Don't do an exercise regime for it. So try to do a little bit more of that. Not getting into too much technical and trade secrets, but that's where the battery modulation aspect can come in.
Wait. You just did an exercise. This is blowing my mind. Like a person, you can exercise it?
Yes. So exercise it works for you and me, and it works for a lithium ion battery. What a lot of people don't realize is that lithium ion batteries were originally designed, and lithium likes this, lithium ions like this rather. They want to stay between usually 40-70%. That seems to be their kind of sweet spot. That is a chemical sweet spot. It's their neutral spot. And if you can drive them up and down within this range, that exercise is actually what they want to do. That is, the chemistry goes, I'm happy. This is where I can just sit for ages and ages and ages. Obviously, you will hit a kind of a point where of no return at some point, but that some point may be 6-7 years from now as opposed to 2 years from now. And obviously, in a world of ROIs, exactly.
That's amazing.
Exactly. So that's something important. Always exercise it, and thinking about human exercise regimes is probably the easiest way to think about the lithium-ion batteries, because it's very, very similar, actually.
Well, can I just give a shout out as well? We talked to Ori Moore. We did a piece on Y-Charge and the wireless power revolution, which is blowing my mind too. And he said something very similar. He's a brilliant physicist like yourself. And he said, I think he said 70% was a good number when I was asking about my cell phone. So it sounds to me like you might know what you're talking about, because Ori Moore is a smart guy. Shout out to Ori.
Ori is very correct. And why he's likely basing off of that is the chemistry of, think of it as kind of a seesaw, two kids on a seesaw. Chemistry operates through diffusion and energy principles. So basically, chemistry wants to say, I don't want to have too much energy in me or too little. I always want to be in balance. It's a very much so a balance concept. And why the seesaw principle comes in is because 40-70% seems to be that tipping point. So if you've ever kind of seen, I use the example of my niece, watching kind of her, if it goes too far, all of a sudden it wants to go even further, and it goes past this equilibrium point. And 40-70% seems to be these break-even points where going a little bit past that, you're past that equilibrium, and now it's pushing it. Now you're forcing it. So if you go too high in battery percentage, what's happening is you're starting to stuff energy into that battery. You're kind of force feeding it a little bit. If you're going below 40%, you're starting to starve it. So that food principle also works. Between 40 and 70, you're giving it just enough calories for it to be happy. You're giving it more than enough, but not too much. And you're keeping that healthy range.
In my head, I'm seeing the image of a hot air balloon, right? And as it starts to sink, you add some heat.
Exactly.
And if it goes too high, well, you let go of the heat, that kind of thing.
That's actually a very good analogy. That's exactly what it is you're always wanting to stay in that kind of central zone.
You seem to enjoy what you do. You seem to actually be happy. What makes you smile when you talk about this and work on this stuff?
I do. Yeah. Personally, this is one of those moments of, the engineering degree comes out where I like to geek out about this. So there's that aspect. The other aspect is also that education concept. It gives me kind of a smile on my face when a customer goes, oh, I never knew that. Wow, okay, I'm now going to do that. And seeing in some of these B2B applications where we are getting massive life out of it, where people are walking away from it more educated, doing better practices. And even if it's one of those of they don't remember where that information came from, the fact that you had an impact on someone's life, I guess, or how they do things, really is a big passion moment. It gives that smile, that helping others.
I love that. It reminds me, we were talking to Chris Devlin of Omnivex not too long ago, and he said something similar. The realm of software is where he works. But he said, look, I'd like you to use my product because I do think it's best. However, even if you're using a competitor's product, I want you to do your technology well because it makes the world a better place. And that's kind of not verbatim. I'm adapting what he said. But the true hardcore OG geeks of the world who are trying to invent solutions and make it better, I just get the feeling that's why I love the digital signage industry, because I keep meeting guys like you who want to change the world. Guys and ladies, everyone. It's amazing.
And that's what drives us, or it drives me personally. And that's why I love going to shows, talking to people, and just kind of being face to face with people. And because you see that reaction, you see that conversation moment, and that wow moment. And it's really, really fun, especially when you see others implementing it. And probably the best kind of compliment is when you see a competitor or someone else start going, well, maybe we should be doing this, because it means you're doing something good and you're you're changing that little corner of your world.